I looked for the hardest Sudoku puzzle on the internet to see if I could solve it with strategies I've featured before on this channel. I did, and now I'll show you how to solve it using 5 logical steps. Click below if you want to give this puzzle a go, and with that, it's solving time. You can actually make a couple solves at the very beginning. If you look at these two 8s and this 8, the only place for an 8 in block 1 is right there. And then with this 7 and these two 7s, you can solve for 7 in block 1. With these two 5s and this 5, you can solve for a 5 right here. And then with these 4s, you can solve for a 4 right there. And that is it for all the easy solving. Greetings, friend. Coloin is one of the more prominent contributors to the Sudoku Players Forum, gifted puzzle setter who dedicated this classic Sudoku to Jim White, aka Mathimagics. Mathimagics was also a big, huge influence on the Sudoku community, sadly passed away around Christmas time last year. Coloin's puzzle is the hardest I've ever seen on the internet. It's got 11.9 maximum rating from the Sudoku Explainer, which means it doesn't get any harder than this. But I'm going to show you how to solve it in 5 steps using almost everything I've ever learned about solving the world's hardest Sudokus. Step 1, we're going to focus here on block 5. This is where we got to look first. For this, you got to apply what we've learned from solving Loki and the Tri-Dragon puzzles I've featured recently. Got to notice is that the only thing left in block 2 is a 1, 2, 3. In block 1, a 1, 2, 3. And in block 4, 1, 2, 3. This pattern is very important. And you may remember from Loki that you have this pattern and this pattern. If these were a 1, 2, 3 here in block 5 with 8, 9, 6 were, that pattern we know you cannot resolve this pattern with just 3 different digits. So you know you have to have an extra digit in one of these. But we have digits right there. So how do we solve this? Well, we just apply what we learned and look at the rest of block 5. So what can else be here? 1, 2, 3, 4, 5, and 7. 7s can't be here. And then the 4s can't be here. And the 5s can't be there or there. All right, and this is what you end up with. And if you remember, when I did Tri-Dragon, we had a scenario kind of like this. And just like if you have it in these 3 cells, like I did with Loki, a pattern like this also will not solve with just 3 digits. You have to have an additional digit, a 4, a 5, or a 7. What we're going to do here is we actually have to focus also on what can be down here in row 7. This is very, very cool stuff. And when I saw it, I thought that was quite amazing how you make this solve here. So this can't be an 8 right there. This can't be an 8. This can't be an 8. It is very important to the rest of the solve. And so you want to look at this pattern and go, you know, you have 2 places for a 7. You have 2 places for a 4. You have 2 places for a 5. What we know is that you know, you gotta have at least 1, 5, 1, 4, 1, 7, right? But we also have to break up the deadly pattern created by this tri-value octagon, also known as a tritagon, also known chromatic pattern. The way to do that is to figure out that you basically cannot have the 4, the 5, and the 7 in a different row, different column in the block. So you can't have, if you have like the 4 right here, and I'll show you pretty quickly. If this was the 4, if this was the 7, and if this was the 5, what you'll see is you're going to have a problem. We're going to have that deadly pattern which cannot be resolved. And the way you'd look at it is, you know, you start with coloring right here. You go blue, yellow, and purple. And then if this was yellow, you know, that would have to be purple, that would be blue, and you'd move on, you know, with the solving here, and oh, that would be yellow, purple. And what you'd see with this kind of arrangement, you know, this would have to be a purple cell. This would also have to be a purple cell because it sees the yellow and blue. This will see the yellow and blue. In any arrangement you do, you'll end up where two of those values have to be the same. You cannot resolve this with just 3 digits. The important thing to pull out of all of this is that the 7, 5, and 4, 2 of them have to share a row and a column. They have to. If they're split up like this, like the 7's the only of the digits in column 5 in row 4, the 5's only in column 6 and only in row 5, and the 6 is only in column 4 and row 6, you will not be able to resolve this puzzle. So what we know is like it's got to be like a 7 and 4 could be both be in the row, or the 4 and the 5 could both be in the column. So it's got to be a clump. And if we do that, then the other thing that will happen is that you're going to have one of these columns is going to not contain a 4, 5, or a 7. I'll show you what I mean. Let's get the colors off, because this is going to make sense here for you pretty soon. All right, so let's get rid of these colors. So what I'm saying is you got to have 2 of the 4, 5, and 7 in the same column. And then you have one of these columns right here in block 5 will contain neither. But we know that if you eliminated the 7 and the 4 from right there, you end up with 4 cells required a 1, 2, or 3. That'd break the puzzle. So it can't be column 4. And if you look here in column 5, if you try to remove the 7 and the 5, you'd see also that 4 cells with a 1, 2, and 3. That'd break the puzzle. So what you know, because of these extra digits down here, what we know is that this column, column 6, in block 5, you can remove the 4 or 5. It has to be gone because 2 of them have to be in one of these other columns. That way, the only thing that works for this puzzle. And so in this step 1, we figured out that this is going to be a nice naked triple, 1, 2, 3, which is going to make that an 8. And you can remove the 1, 2 right there. You can actually remove the 8 now and solve this for a 3. This is the first break-in to this puzzle. And the way we did it is by knowing how that trigon, tri-value, autogon pattern works. And before I proceed to step 2, I want you to know that you may be able to solve hard Sudoku faster than you think. I offer monthly reward puzzle packs. The real value, you get to learn and practice techniques that give you the foundation to solve much harder puzzles than you ever thought possible. You join the Smarty Party like my new members, Striker126, Dave San Calente, and Dale King. I'll send you my next pack along with a new one each month. Give me the correct solution, I'll give you a video shout out like Paula Phoebe, Aaron Wells, John Brown, Don Malone, and Carol Emmerich, who all solved my November reward pack. Click the pinned comment today because you want to solve puzzles better, right? And so by putting this 8 and 3 here, now we're going to get a little bit more solved to get into step 2. And so what you notice is with this 1, 2, 3, this has to be now a 4, 5 naked pair. And then we can see with this 5, you can actually solve for the 5 here, and you can solve for the 4 right there, right? Because we removed those from those 2 cells. We still have 2 7s to worry about. But now with these 5s and these 5s, you can solve for a 5 in block 6. So we've made some progress. This is great. Let's look now across row 7. Because you have this 3, you can remove the 3s from right there. That gives you a 1, 2. And now we're going to move on to step 2. Step 2 is to find the column 7 restriction. This is the next place where you need to look. Well, you may notice if we fill this out, you have a 5, 8, 9. We need a 1, 2, 3, 4, 6, and 7. You might be like, Timberlake, I don't see a lot of restriction right here. Why are you focusing on these 2 cells? And you will see why I'm focused on this column and certain cells involved. This can't be a 6. This can't be a 4. This can't be a 4 or a 6 or a 7. And then you come down in here, and this can't be a 1, 2, or a 3. Okay, so we filled out blocks, column 6, and then we want to find out what the restriction is right here, if there's any restrictions on what we can do with this column. In order to do that, you actually want to fill out the rest of block 6, because I'm going to show you something really cool here. And I got this tip from Shye. Shye actually placed a solve of this puzzle in the CTC Discord server, and I needed a little bit of help, so I looked at this hint from Shye to do this, and it's awesome. This is the way to get through step number 2. Okay, so that's what those cells can be right now. What you might see, and what you have to ask yourself is, can you put a 4 or 6 in this cell? Right? Can you put a 4 or 6 right there? The issue is, if you put a 4 right there, you'll notice that's restricted with these cells, so you end up with a 6, 7. So you have a 4, 6, 7 naked triple. Well, what that does is it then eliminates the 4, 6, 7 from the rest of this column. You put a 1, 2, 3 here, well, this can no longer contain a 1 or a 3, and this cell can no longer contain a 2. And what you see is that you'd have to put an 8. It's the only possibility in these two cells. That cannot happen. And then if you put a 6 up there, because of the way this 4, 6, 7 naked triple works, now you get rid of the 6's there, and you would remove the 4, 7 from right here. You remove the 6, 7 from right there. Same thing, you end up with this 1, 2, 3 naked triple, which removes the 1, 2, and 3 from the other cells, and you have to put an 8 in 2 spots. This strategy, this is a type of Sudoku firework. And there's a much fancier name for it, but the basic premise is if you jam everything in this column, then you leave too many open cells here in the block. And so we have to prevent that pattern by removing the 4 and the 6 from this cell. It can't be a 4 or 6. I just showed you that using this Sudoku firework. And Shye is an expert on these fireworks so much, I've solved a couple of her puzzles using that technique. I'll put one at the end for you to check out, and I teach you everything you need to know about Sudoku fireworks. But that is step 2. And now you see you have a 1, 2, 3 right there. This can be a 4, 6 naked pair, so we can add that. And we have to go on to step 3. What you've created is a 1, 3 right here. You have a 1, 2, 3 here, and a 1, 2, 3 here. You actually have to notice what these 3 cells have in common and how they are related, because step 3 is to find a remote triple. Again, I'm borrowing an idea from Loki. This is one of the steps in solving the very hard puzzle by Philip Newman called Loki. And you have to ask the question, and we're going to use a little bit more coloring. Are these 3 different, or 3 different digits? One's a 1, one's a 2, one's a 3, or are they set up where this is one of the digits and then these two happen to be the same? Well, what you're going to see is if these two are the same, right? If this is a 1 and these are both 2's, how would that affect our coloring? Well, what you'd have is that the purple cell has to be one of these. So let's say it's right there. So of the 1, 2, and 3, you have a 1, 2, 3 here. This would be the other value. This would be the third value. It could be there or there. If this is the purple cell would go right here in block 4. But where would the purple cell, the purple value, go in block 5? It couldn't go anywhere, right? And the reason it can't go anywhere is that these cover the 2 rows. And very quickly you'll notice the only other place the purple, which would be the third value, can go in this column and in this block is right here. Because this other one either would have to be the 4 or the 7. If this is purple, you'll see that purple goes right there in block 4, and then you have no place to put purple in block 5. So what you know is these 2 cannot be the same digit. They can't be the same digit. That you have to figure out, and so that creates what we call a remote triple. And so we know that these are 3 different values. So this is yellow. This would then be the third value. You know, this could be a 1, that could be a 2, that could be a 3. The point is different colors represent different values. And now we can use that to help solve this the puzzle here. So the remote triple, very important. And some people, they really appreciate the tips that I give like this so much that they'll buy me coffees, like Melvin Fern, Les Kirby, Charles Petty, and Robert Lau. Thank you so much for supporting Smart Hobbies. What we can do is we know now the purple has to be either here or here. And why am I saying that? Because it can't be in these 2 cells. And this is the yellow, this is the blue. So the purple's got to be there or there. And we can make a little bit more deductions. Because this is purple and that's yellow, this has to be blue, and this would have to be purple. Okay? And then what you'd know is that this purple cell right here can't be in this cell of the 1, 2, 3 triple, so it has to be in one of these 2 cells, right? This value has to be here, here, which restricts it to these 2 cells here in block 5. That's important to know. And so by doing that, we now can make a little bit more deductions here. And so we have 2 cases to consider. The purple over here, since it's right here, the purple cell could be this one, right? In column 1, if it's not up there, it can't be there, it's got to be in one of these 2 cells. So you're going to see really quick, there's something here, a deduction we're going to make. We're going to be able to figure out where the 7 goes. If purple's right there, that's yellow, that's blue, that's yellow, okay? And then this is blue, this would be yellow, and now you'd see that the blue and the yellow and the purple all look at this cell right here. So this could not be a 1, 2, or 3, right? Because the blue value would be here, the purple value is here, the yellow value is right there. Like, okay, Timberlake, what about the other case? So the other case, if the purple cell or value is not right there, in column 1, it can't be here, it's got to be in one of these cells. And if that's the case, then this has to be yellow, right? Because you got the blue and you got the purple, which makes this your purple value right here. That's going to be your blue. And then with the blue and the yellow there, this is going to be your, or excuse me, purple and yellow. That's going to be a blue, that's going to be a yellow. And then what you'll see is now the blue value, the yellow value, and the purple all see this cell again. Either case, this can never be a 1, 2, or 3. Now you can solve this cell using that remote triple. Now we know we can solve this cell for a 7. We have to be able to solve that for 7. This is beautiful stuff. And now we can make some more solves. We're going to remove the colors. We know that that's going to be a 7. You can remove the 7 from right there. You can remove the 7s from right here. And we're going to make a few more deductions here. Okay, we've created a few more naked triples, and we're getting close to step 4 now. With this 1, 2, 3 here, this has to be a 7, 9, which makes this a 3, 6. And you can remove the 3 from right there. It's of interest, but we're going to remove that. Now you have this 1, 2, 3 naked triple right there. So that means this can't be a 1, 2, 3 anymore. And this can't be a 1, 3. That's a 6, 7. So we're going to put the 6, 7 right there. Also, you'll see that now you have this 4, 6, 7 naked triple right here. So this can't be your 4. And so you restrict now the 4, 9 to these 2 cells. Okay, 4, 9 can't be anywhere else in this block. So let's remove that color. And we're moving on now to step number 4. Step number 4, we're going to look at the column 3 restrictions. This is a really neat way to move forward in this puzzle. I've gotten through a lot of the hard parts, but now you just got to ask a few more questions to get a few more solves. You notice down here you have a 4, 6, 7, 8, right? The 8s are restricted to these 2 cells. Where are the 8s restricted to in column 3? They got to be in one of these 2 cells as well. And then here in block 6, they're going to be one of these 2 cells. There's a lot of restriction with the 8s. And if you look here, this can be a 1, 3, or an 8. And because of the 1, this could be a 2, 3, or an 8. And so you have to ask yourself this question. can this cell right here be an 8? Can it be an 8? If you put an 8 right there, is that okay? And what you're going to see is now you restrict the 2's in this column to these 2 cells. And then you restrict the 2's in this column to these 3 cells. So this is a strategy I've featured many times on my channel before. It's an advanced strategy, not that you need for very extreme puzzles, but I cover it quite a bit. What you'll see is that if this cell, purple cell, wasn't there, what you'd have is an X-wing of 2's. A 2 would have to be there and there, or there and there. And you can eliminate all the other 2's along row 6 and row 1. So this cell right here cannot be a 2. If this, but it is here, so it's a fin. If this is a 2, that can't be a 2. If it's not a 2, you end up with an X-wing of 2's. And so this cell still couldn't be a 2. So if this is an 8, you end up with this finned X-wing, which removes a 2 from right here. And then what you'll see is that you would put an 8 there. And now you would eliminate both places for an 8 in block 9. So you have 4, 6, 7 for 4 cells. Can't do it. Break the puzzle. So you cannot put an 8 right there. You can remove that as an 8. This is really nice stuff. And so what you know now is, since that can't be an 8, this cell has to be your 8 in column 3, which means this now has to be the 8, and this cell has to be your 8. Nice. And now we're going to look for another column 3 restriction. This is another part of step 4. And you want to look here and go, what did we create? Can we actually solve this cell now? And if you look in column 3, you'll see that the 1's are in the same place as the 2's were in the other scenario. This is the fin. If you're looking at just the 1's now, if this is true, this can't be a 1. If it's not true, you'd have an X-wing of 1's in the blue cells. And the ones there and there and there, that would still not be a 1, right? Because you put a 1 right here, then in columns 3 and 7, the only place to put a 1 would be row 1, right? Hopefully you understand. If I say that's a 1, you eliminate those 1's, and then you have to put a 1 here and here in row 1 to finish column 3 and 7. That can't happen. So we know that this can't be a 1. So this is a nice little thin X-wing. Remove that. Now you can solve this cell for a 3. So we found those restrictions in column 3. That was step 4. Now we're going to move on to step 5. We're going to get closer to solving the rest of this puzzle. And before I show you where to go next, I want to thank you for your support. I donate a portion of my proceeds to Agape International Missions. It helps fight human trafficking around the world, particularly in Cambodia. Last month, we raised $56 to stop human trafficking, bringing our yearly total to $237. You can follow my volunteer efforts with AIM on my Smart Hobbies Instagram page. But by solving this for a 3, we're going to be able to make some more eliminations throughout this puzzle. Now these can't be 3's, so the only place to put a 3 now in column 7's right there. So those can't be 3's. And so now you can solve this for a 3. You can solve that for a 3. No 3 right there. No 3 right here. And no 3 right here, because in row 6 you already have a 3. All right, so you can solve that for a 3. And then with this 3, you can solve this for a 3. Eliminate the 3's from right there. Nice. So we solved all of the 3's except for now we got to do this one. There's your 3, and that's going to be your 6. And so you get a little bit stuck again. You're like, okay, Timberlake, I thought we had this puzzle filled out. And so this step 5, I'm going to set it up. It's a very fun way to end this puzzle. One of my favorite strategies involving buy value cells. We just got to fill out the rest of the cells for you to see what I'm talking about. So this can be a 1, 2, 7, or 9 in block 3, because we already have the 3, 5, 8, and the 4, 6 naked pair. That can't be a 1. This can't be a 9. This can't be a 2, because the 2 in the column, and this can't be a 7. We just created 4 more buy value cells. How about down here? This can be 1, 2, 5, or 9. 1, 2, 5, or 9. This can't be a 5. This can't be a 1. This can't be a 9. And this can't be a 2. We created 4 more by value cells. Now, you look around here, we can make a little bit more trimming there because that's 6. That's a 4, 7. And then if you notice, because of this 4, 6, 7 naked triple, the 4s are a claiming pair, right? They have to be somewhere in column 7. They're restricted to column, they're restricted to that column in block. So this can't be a 4. Now, if you see here, every cell that's remaining is a by value cell, except for this one. This one has 3 digits remaining, 4, 6, 7. When you have this situation, the puzzle has a unique solution, which we know it does. You have found a by value universal gray +1 strategy. And what we know is that in order to preserve a unique solution, this cell has to have the value that's going to disrupt a deadly pattern. If this was not a 7 and you solve this for a 4 and you solve all these cells in this puzzle, you could go back and then put in a 6 and you'd get all the opposite values. If it's a 6, that'd be a 7 now, that'd be a 4, and you'd go around and solve the puzzle. You'd have 2 solutions. We know the puzzle doesn't have 2 solutions. So what you do is you look for the candidate that appears 3 times in the block, in the column, and in the row. And you'll notice that a 7 appears 3 times. And so you can solve with certainty using my nice little shortcut this for a 7. And if you don't believe me and you want to validate it with an XY chain, which you can always do, start right here, end right there. You'll notice that you can remove the 6 from this cell and you'll be able to solve it for a 7 and move on. But by putting the 7 here, what does that do for our solving? Put a 7 here, you know, that's a 6, that's a 4. This is where it gets fun. That's a 4, that's a 5. That's a 9, that's a 7. Nice. All right, that's a 1. That's got to be your 9. There's your 2, there's your 5. So far, looking good. 2, 1, 2, 1. Nice. All right. 2, 1. Looking good there. 2, 1, 2, 1, 2, 1. Yep. And then we'll look on and go 6, 7, 1, 7. All right. 9, 2, and then we got the 9 and the 4. We got the 4 here, and our last digit now is a 6. Learn more about the fireworks strategy in this next puzzle by Shye. Thank you so much for watching.